Hey guys, and welcome back to another video. Now, there are many operations in MATLAB that behave in an element-wise manner. So, the operation is, which means that the operation is performed in each element of the matrix independently. Now, here I have a matrix M. Now, the sign function. So, if I do the sign function of matrix M, MATLAB returns to me a vector containing the sign of each element in matrix M. So sign function is an example of an of an function which behave in an element-wise manner. Then there are many such functions in MATLAB which behaves in an element-wise manner. Some other examples are the cos function, log function, round function, then the square root function. So all these are examples, and there are many more such functions which behave in an element-wise manner. Now, there is there is a feature in MATLAB that automatically adjusts the sizes of arrays to enable element-wise operations, even if the arrays have a slightly different dimensions. So this will allow you to operate on arrays of different sizes as long as one of the dimensions is compatible. By compatibility, I mean that the size of one of the dimension is same, or by compatibility I mean the size of both dimensions are the same, or one of them is one. So here in this case, my vector A is a 3 by 1 matrix, and my vector B it's a 1 by 3 matrix. So when I write C is equal to, when I prompt C is equal to A plus B, what MATLAB does is that MATLAB expands vector A and vector B and add these vectors together. So um, when MATLAB expands vector A, I get a second row containing 1, 2, 3, and a third row containing a third column, a second column containing the elements 1, 2, 3, and a third column containing the elements 1, 2, and 3. And here, when MATLAB expands B, second row containing the elements 10, 20, and 30, and a third row containing those elements get added to matrix B, and MATLAB add these two expanded matrices together to give us the final answer C in this case. So this is how implicit expansion works in MATLAB. Now let's look at another example of implicit function. So here my first vector, it's a 3 by 2 matrix, while the second vector is a 1 by 2 vector. So what MATLAB does is that since the one of the dimensions of k is 1, MATLAB expands the vector k. So it adds a second row and a third row containing the elements 4 and 5 to make k a 3 by 2 matrix, and a- add the matrix J with the expanded matrix K, which gives us the answer, which gives us this resultant matrix. Now, there are many statistical functions which we can perform on arrays in MATLAB. Now, statistical functions like mean, minimum, max, they all are meant to work on sets of data rather than single values. You can use the, so here see the minimum function, it finds the minimum value inside the vector. The maximum function, the max function, it returns the maximum value inside the vector. The mean function finds the average of all elements inside the vector v, and the median function, it returns as the median of elements inside vector v. Now, suppose you have a matrix. How does MATLAB calculate the mean of matrices? So MATLAB has a default interpretation of how data is stored in a matrix. It assumes each row as a different observation or case, and each column as a variable. So, for example, suppose I am doing a survey on a certain population, and I am recording their height, weight, and say blood pressure levels. Uh, so the first row will contain the weights of different people in the population. The second row, their height, and the third row, their BP levels. And each column, the first column will contain the weight, height, and BP level of the first person. The second column will contain these values, the height, weight, and BP level of the second person, and the third column will contain height, weight, and BP of the third person, and likewise it goes. So um, in MATLAB, the each row represents different observation or case, and each column represent a different variable. So the command mean of x treats the columns as independent and returns a row vector containing the mean of each column. So here I have my matrix M, and when I prompt mean of M, MATLAB returns a row vector containing the mean of each column. So 4 is the mean of the elements in the first column, 5 the mean of elements in the second column, and 6 the mean of elements in the third column. Now, what if we want the mean across the rows instead of columns? For that, mean has an additional input which we can use to specify which dimension to apply the mean to. Now, mean of the syntax, this is the syntax, mean of the name of the matrix, then dimension. So if I write mean of capital M comma 2 and run this code snippet, MATLAB returns to me a column vector which contains the mean of elements in each row. So 2 is the mean of elements in the first row, 5 is the mean of elements in the second row, and 8 is the mean of elements in the third row. So now the dimension value 2 here means we want the average over the second dimension, that is across the rows. Now, some statistical functions like min already accept two inputs. So when you pass min over two arrays, it compares them element wise, returning the smallest of each pair of corresponding values. So this command min x comma 2, so sorry, min m comma 2, this finds the smallest of each element x, each element m, and a 3 by 3 matrix containing element 2, only element 2. So, and not the minimum of each row of m. So in such cases, you can specify the dimension not as the second input but some other input. In this case, when I type min m uh, square brackets 2, I get the mean uh, of the second dimension, that is mean of each rows, minimum in each rows. So the minimum value in the first row is 1, minimum value in the second row is 4, and minimum value in the third row was 7. So we use an empty array here as the second input so that we are not comparing the matrix M to anything and then the dimension as the third. Now other functions like std, min, max, cov, median all work the same way. We will see many of these functions while doing problems in statistics and linear algebra. Now you can also get the mean, minimum and maximum of all elements in an array by specifying the dimension as all. So if I write min m is equal to min minimum of n, so this returns me the minimum value of all elements in the matrix M. If I type max m is equal to min, now this function will return to me the maximum of all elements in the matrix M, and average m, this will return to me the average of all elements in matrix M. Now sorting arrays in Matlab is a straightforward with the sort function. It allows you to sort the elements of an array in ascending or descending order. By default, sort will arrange the elements in descending order. So when I run this command snippet here, so the sort function will return the sorted vector v here. Now, the sort function can also return a second output argument that provides the indices of the sorted element. So here in this case, this ARR, this contains the sorted array, and IDX contains the corresponding indices of the elements um, in the original array. So 12 here was the first element in our original matrix. The second 12 here was the uh, 11th element in the original matrix. 25 was the sixth element. Then 38 was the seventh element. 45 the second element, and so on it goes. Now you can sort data from the now you can sort data from the largest to smallest using the descent option for sort function. So uh, if I add descent here, Matlab will sort data from the largest to the smallest. So here in this case, x sorted is the vector v vector vec sorted from the largest to smallest, and I and d contains the corresponding indices of these values. Now when sorting matrices, sort operates on each column differently as each column separately, just like the mean function. So when I run this, Matlab sorts each column separately. So here, so 1084, after sorting, the Matlab will give us 4810. So after sorting 733, Matlab will return 337. 765 567. So this is how sort function works in MATLAB. Now we have the cumsum function. The cumsum function calculates the sum of an element with all the previous elements of a vector. If the input is a matrix, the sums are calculated by column, and the output is a matrix of the same size. So here we have the cumulative sum of a vector. So this will give me the cumulative sum of vector A. So the first element in B will be 1. The second element will be 1 plus 2, the sum of the first and second element, which is 3. The third element in B will be the sum of first, second, and third elements of the original vector, which is 1 plus 2 plus 3, which is 1 plus 2 plus 3, which is 6. Then the fourth is the sum of all four elements of the original vector, and the fifth element in B is the sum of all five elements in the original vector. Now, this function B is equal to cumsum of A. This returns the cumulative sum of matrix columns of A. So, here the first element we have 1. The second element in the first column is the sum of the first element and second elements of the sum of the first and second elements of the first column in A. And the third element here is the sum of the first, second, and third elements in column in the first column of A. Similarly, we have columns 2 and 3 of matrix B. And if we want the cumulative sum in a raw major fashion, we have this command over here. So uh, so when I run this command over here, the second command over here, I get the cumulative sum of matrix rows. Now cumulative sum with reverse direction B will be calculated. So here if I append reverse here, we get the cumulative sum with reverse direction B, which the so this will calculate the sum from the end to the beginning of each row. So when I hit enter, so this when I hit enter here, this will calculate the sum from the end to the beginning of each row. So in this case each row. So here I have 3. So the second element here, this is 3 plus 2. So the third and second elements, the sum of third and second element, 3 plus 2. Then we have here 3 plus 2 plus 1 will be here as the first element of B, which is 6. So that is how cumsum function works in MATLAB. Now we have the backslash operator. So now the backslash operator, it solves the linear equation AX is equal to B, where A is a matrix, like a system of equations, B is a vector, and X is the vector of unknowns you want to find. So to find X, we simply write X is equal to A backslash B to find the solution X. So if I have the matrix A, so let me generate a random matrix A. Now, um, I think it's better to, do this with some non-matrices. So if I type a matrix here, some matrix 2, 1, 2, 2 minus 1, 1, 1, 3, minus 1. So this is an invertible matrix. Then I type B, which is 0, 10, 5. So this represents, so these two, they represent the equations 2x plus y plus 2z is equal to 0. Then 2x plus 2x minus y plus z is equal to 10, and x plus 3y minus z is equal to 5. So these equations, this system of linear equations is represented by A and B, and to find the unknown values x, y, and z, we just need to type x is equal to uh, A backslash B. So when I run this code snippet here, I get the value of x, y, and z. So x is 6.53 something, y is minus 2.3, and z is minus 5.38 something. So this is how you use the backslash operator in MATLAB. Now there are some key things to remember. Our matrix A, this must be invertible for the solution to exist. This means that its rows or columns should not be linearly dependent. Now, multiple solutions may exist if A is singular or non-invertible. In such cases, backslash provides one particular solution from the many solutions. And now, if the system of equations is underdetermined, that is, more unknowns are there in in these equations than the number of equations, backslash provides the least squares solution, minimizing the error in the equations. Now, this was all about the backslash function, and let's look at some other important functions that we can apply on MATLAB. We have the det function, det function, which returns the determinant of the matrix A. So the determinant of matrix A is 13. Next, we have the inv function, which returns the inverse of matrix A. So when I run this here, I get the inverse matrix of matrix A. Then we have eig A, which returns as the eigenvalues of vector A. Now, remember the actual operations, you can perform depend on the dimension and types of matrices that you are dealing with. So this was all about arrays, matrices, and matrix operations in MATLAB. We will see a lot more of these when we are learning linear algebra and statistics. So thanks for watching. Bye.